Alright, now just before we move on, let's get some terminology out of the way, shall we? Now, you'll notice that when we look along this graph, we determine what x is, and then we read off and see as a consequence what y happens to be. We can do it the other way around, but we have y here, just one y here, and we see that we write that that's 4x. That's equal to 4x plus 5. Now, of course, the value of y, as we've seen here, depends upon, in that case, what the value of x happens to be. We say that, and this is the terminology, that y is a function of x. The value of y, whatever y happens to be, depends on x. If x is 0, then y is 5. If x is 1, then y is 9. If x is 2, then it's 13. If it's 3, then it's 17, and so on and so forth. And you'll notice here, for every 1 we go up in x's, we go up 4 in terms of y. For each one value of 1 that x goes up, y goes up for a value of 4. So y depends upon x. We say that y, let me just write it down here, and I'll write it in light blue so I hope you can read it. Y, well, you can read the blue. It's a question of whether you can read my writing, which is so terrible. Y is a function of x, and that simply means that the value of y depends upon that of x. And one of the ways to think about it is if we have a whole group of all the natural numbers here, we just jiggle them up. Suppose we write them on cards and we throw them all down, or a large number of them, and then we've got the natural numbers here. Another set of cards, and we've written them all on. Then this function, this 4 times x plus 5 function, will mean that if we've got a number here, if these are the x's, if we've got a number here which is 3, for example, it takes 3. Let me just change color. It will take the number 3. This function will take the number 3 to the number 17. These are the y's. That's the number 17, and that's the number 3, just that. Whoops. My writing is bad. It will take the number 4 to 21. Let's suppose this card is the one with number 4 written on it, and this card over here is the one with 21 on it, and so on and so forth. This function just takes a value of x and it takes it to a value of y. And these are the values of x that are taken to these values of y. That's what a function does. It takes one number to another, or maybe it's more than one. There are different sorts of functions, but we'll come on to that a little bit later. We don't really need to know too much about functions right now, but that's just a matter of straightforward terminology, and you'll hear that in ordinary English. So somebody might say, for example, in English, just talking, "Oh, what time do you think Fred will be here?" Well, somebody might reply, that will be a function of when he gets off work, which will mean simply that it will depend upon what time he gets off work, and therefore what bus or train he can catch, or what time he can get in his car to drive, or whatever the case may be. Alright, now in the last video we talked about graphs, and we talked about graphs which were of, these are diagrams if you like, a form of maps is another way of putting it, but these are diagrams where we take a value for values of y and we plot them against values of x, and what we said is if that relationship, if that line is straight, for example, then we call it linear. Now, And we also said that where we have an equation of the form y equals something of x, then we said that y is a function of x, a function, which is just to say that it depends. Its value depends on what x happens to be. Y is a function of x. Now, we can draw a graph of this y equals x, whatever this function of x, and if it's a straight line, oh, I've misspelled that, I put liner, it should be linear. And if it's a straight line, then it's a linear graph, and moreover, this function, whatever it happens to be, is termed a linear function. Now, what will happen when we have functions which do not involve just an x to the power of 1? Suppose, for example, that we have a function y is equal to x times x. And what's x times x? That's just another way of saying x squared. So what we have is y is equal to x squared. Alright, now let's just do what we did previously and set up a little table of the values of x and then the values of y. And we'll do exactly as we did in the last presentation. And let's just work things out. Let's suppose we'll only go from 0 up. 0, 1, 2, 3, 4, 5. Well, if x is 0, y is 0 times 0, which is x squared. And what's 0 times 0? Well, it's 0. And if x is 1, then y is 1 times 1. What's one lot of 1s? Well, it's just 1. And if x is 2, then y is 2 times 2. What's 2 times 2? It's 4. And if x is 3, then y is 3 times 3, and what's 3 times 3? It is 9. And if x is 4, then y is 4 times 4, and what's 4 times 4? It is 16. And if x is 5, then y is 5 times 5, and what are 5 lots of 5s? They are 25. Now let's draw a graph of that function, the function of y equals x squared, and we'll see if it turns out, in particular we're wanting to know if it turns out to be linear. Well, let's again do our what we call axes, and that's our y-axis, up and down. We generally put y on that vertical axis, and we've got x here. That's our x-axis, and here is, let's start with the x's. We have 0, and we go up to 5, don't we? 1, 2, 3, 4, 5, let's say, and then we could go on and on and on up here. And what about y? Well, y is 25. Let's suppose that that's 25, and let's suppose that that then is 20, and let's suppose that's 15, and that is 10, and that is 5. Those are our scales. Right, now let's plot our numbers. Well, when x is 0 here, that's 0. So when x is 0, what's y? Well, y is 0, so it's there. 0, 0, where those two axes cross. When x is 1, well, x is 1 here, all the way up here. What is y? Well, it's 1, so it's about, it's 1/5 of the way there, so it's about there. I'm just going to put big dots there. Not particularly accurate, they should be a little more accurate. When x is 2, then y is 4, so 2 along the x's, and then we go up to 4, it's about there. And when x is 3, then y is 9. So 3 here, let's go up 9 to about there, isn't it? About there. And then when x is 4, y, I'll just take that out, y is 16. So that's about there, isn't it? 16, let's go across here, where it crosses the line up from 4. It's about there. And when it's 5, we've got 25. That's about right, isn't it? Somewhere around there. That is directly above the 5 and across from the 25. Just about there. Anyway. Now here's something interesting. Let's see what happens when we go negative. Take negative values of x. That's the same. So this is negative 1. And this is negative 2, and this is negative 3, and negative 4, and negative 5. Now let's see what we have. Well, let me put these numbers next to here. Let's suppose we have negative 1, negative 2, negative 3, negative 4, and negative 5, and then I'll put the values of y here. Well, if x is minus 1, then y is minus 1 times minus 1. What's that? It's plus 1. And if x is minus 2, y is minus 2 times minus 2, which is simply plus 4. And if x is minus 3, then y is minus 3 times minus 3, which is 9. And if x is minus 4, then y is minus 4 times minus 4, which is 16. And if x is minus 5, then y is minus 5 times minus 5, which is plus 25. In other words, it's exactly the same. So as when x is positive. So let's just plot those values here. So we have when x is minus 1, y is 1. So when x is minus 1, y is 1. And when x is minus 2, y is plus 4. So minus 2 plus 4. And then when x is minus 3, which it is here, that's supposed to be negative, the negative sign got also. Minus 3, then x is y is 9, I beg your pardon, about 9, it's about there, somewhere like that. And when x is minus 4, what is y? X is minus 4, y is 16, which is just up there. And when x is minus 5, y is 25. X is minus 5, let's go up there. Now, let's just take a look at this, because here we have the graph, and it sort of looks an interesting shape, doesn't it? Whoops. Let me just change color here, and I'll try and draw this as well as I'll draw it as well as I can, but that isn't really, that's supposed to go through these dots, and just touch the bottom there, and it goes up and up and up and up and up. So this is this a linear function? Is y equal x squared a linear function? No, it isn't, because it's not a straight line, is it? It's what's called a parabola. It's a parabolic function. It's strange. This is the graph of the function, by the way. It's really a pictorial way of depicting this function y equals x squared. The way of depicting it in a picture form. And if we want to find out what y happens to be when x is 2.5, we can either put in 2.5 here, and 2.5 times 2.5, or we can just read off from the graph by looking up from the 2.5 and then seeing what it'll be on the y-axis there.